When you stand at the base of the Great Pyramid and look at those stones, the idea of ramps and wet sand feels like trying to explain a smartphone by saying it's just a very fast carrier pigeon. The ramps plus wet sand plus copper chisels plus 20 years story is the architectural equivalent of saying Beethoven composed symphonies by hitting rocks together really rhythmically. You've got 2.3 million blocks, some weighing 80 tons, cut and placed with sub-millimeter precision, aligned to true north within 3/60 of a degree. And the whole thing sits on a leveled bedrock platform that's flat to within 15 millimeters across 13 acres. And the mainstream explanation still boils down to lots of sweaty guys, some sleds, and a really long weekend.
Cute theory doesn't survive contact with the actual math.
The Great Pyramid of Giza continued to challenge the parameters of conventional Egyptology, necessitating a multidisciplinary examination of the evidence supporting high-technology building methods. The technical achievement represented by the Great Pyramid is defined by a level of precision that exceeds any known utilitarian requirement for a tomb. Its orientation is within 5 arc minutes of true north, a feat that implies a sophisticated understanding of stellar movement and geodetic positioning. Imagine standing in the king's chamber of the Great Pyramid. You're surrounded by massive blocks of red granite, each weighing up to 80 tons. These stones were quarried 800 kilometers away in Aswan and somehow transported, lifted, and placed with such precision that the joints between them measure just 1/125th of an inch. You can't fit a knife blade between them. Now imagine the conventional explanation. Thousands of workers with copper chisels, wooden sledges, and rope. No wheels, no pulleys, no machinery as we understand it. Does that story actually make sense? Here's what we know for certain. The Great Pyramid contains approximately 2.3 million stone blocks, with a total weight of 6 million tons.
Its base covers 13 acres and is leveled to within 1 inch.
Its alignment to true north is accurate to within 3 to 5 arc minutes. That's a precision that rivals modern laser-guided construction. And it's not just Giza. At the Serapeum of Saqqara, there are 24 massive boxes carved from granite and diorite, each weighing between 70 and 100 tons. These boxes exhibit tolerances within 1 micron. 1 micron. That's thousandths of a millimeter. Their lids create hermetic seals when closed. These boxes sit in cramped, dust-filled tunnels where there's no evidence of soot from torches, no room to maneuver wooden sledges, no logical explanation for how they got there using Bronze Age technology. And then there's Baalbek in Lebanon, where a single stone block weighs 1,650 tons. It's called the Stone of the Pregnant Woman, and it's still sitting in the quarry, abandoned. If the ancient builders could move that, they could move anything. So what if the conventional story is wrong? What if the ancient Egyptians didn't build the pyramids with brute force and primitive tools? What if they used something far more sophisticated, something we've only recently begun to rediscover? What if they built the pyramids with sound?
Welcome to today's episode. Over the next hour, we're going to explore one of the most radical theories in alternative archaeology.
That the ancient Egyptians utilized acoustic levitation, vibrational frequencies, and piezoelectric energy to manipulate massive stone blocks. We're going to examine the engineering evidence, the historical accounts, the modern scientific parallels, and the disturbing possibility that our ancestors possessed a lost science of sound that allowed them to literally make stone float. This isn't fringe pseudoscience. This is physics, geology, archaeology, and ancient testimony all pointing toward the same unsettling conclusion. We've fundamentally misunderstood how the greatest structures in human history were built. Let's dive in.
Segment 1, the precision problem, engineering that shouldn't exist.
Before we talk about how the pyramids were built, we need to establish what they actually are, because the moment you understand the true specifications of these structures, the conventional explanation starts to fall apart. Let's start with the numbers. The Great Pyramid originally stood 146.6 meters tall. That's 481 feet, or exactly 280 Egyptian cubits. Its base perimeter is 921.45 meters, with each side measuring 440 cubits. The structure contains approximately 2.3 million blocks averaging 2.5 tons each, with some blocks in the King's Chamber weighing up to 80 tons. But it's not the size that's the problem. Humans can build big things with enough time and manpower. It's the precision that defies explanation. The base of the pyramid is level to within 1 inch across 13 acres. Think about that. 13 acres is almost 10 American football fields, and across that entire expanse, the variation in height is less than 1 inch. To achieve that today, we'd use laser levels and sophisticated surveying equipment. What did the Egyptians use? During the Old Kingdom, around 2500 BCE, when the pyramid was supposedly built, the North Celestial Pole wasn't marked by Polaris like it is today. It was marked by a star called Thuban, which was about 2 degrees away from the true pole. To achieve the pyramid's alignment, the builders would have needed to use advanced techniques like the simultaneous transit method, tracking multiple stars as they crossed a vertical line onto the horizon, or the solar gnomon method, tracking the shadow of a vertical rod throughout the day to establish an east-west baseline. These are not primitive methods. These are sophisticated astronomical and mathematical techniques. And then there are the casing stones. The pyramid was originally covered with thousands of smooth white limestone blocks from Tura, fitted so precisely that the joints between them measured only 1/125th of an inch. Modern stonemasons, using diamond-tipped saws and precision tools, struggle to replicate that level of accuracy. A knife blade can't fit between those stones. Neither can a piece of paper.
Why would tomb builders care about that level of precision? If you're just building a monument to a dead pharaoh, close enough is good enough.
But if you're building a precision instrument, a machine designed to resonate at specific frequencies or channel specific energies, then every measurement matters. And that brings us to the internal chambers. The King's Chamber is constructed entirely from red Aswan granite, transported over 800 kilometers from southern Egypt. The ceiling is formed by 9 massive granite beams, each weighing approximately 50 to 80 tons. Above the King's Chamber are 5 relieving chambers, also made of granite, arranged in a specific configuration that mainstream archaeology says was designed to distribute the weight of the pyramid above. But mechanical engineers looking at these chambers have a different interpretation. The relieving chambers aren't just structural support, they're acoustic cavities. The specific dimensions and the arrangement create a resonance system, a stack of chambers that can amplify vibrations and focus acoustic energy. The King's Chamber itself has specific dimensions, approximately 10.47 meters long, 5.23 meters wide, and 5.81 meters high. These aren't random. Acoustic testing has shown that the chamber resonates at a fundamental frequency of approximately 117 Hz. That's well within the range of the human voice, and it's also a frequency associated with cellular resonance and healing in modern sound therapy. Inside the King's Chamber sits a granite sarcophagus, carved from a single block of stone. When struck, it rings like a bell, producing a deep, sustained tone. Acoustic studies suggest the sarcophagus is coupled to the chamber, meaning sound energy in the room is largely transferred into the stone itself. Why would you design a tomb this way? You wouldn't. But if you were designing an acoustic resonator, a chamber meant to amplify and focus vibrational energy, this is exactly what you'd build. Now let's travel to Saqqara, about 30 kilometers south of Giza, to the Serapeum. The Serapeum is an underground complex of tunnels containing 24 enormous boxes made of granite and diorite. Each box weighs between 70 and 100 tons. They're carved with such precision that their tolerances are measured in microns. When you place the lid on one of these boxes, it creates a hermetic seal. Air doesn't escape. The boxes sit in niches along narrow tunnels. There's no evidence of ramps, no evidence of the massive infrastructure you'd need to move 100-ton objects. And most tellingly, there's no soot on the ceilings or walls. If workers were down there with torches for months or years, carving and placing these boxes, there would be soot everywhere, but there isn't any. The conventional explanation is that these were burial chambers for sacred Apis bulls. But when you look at the engineering, that explanation makes no sense. You don't need micron-level precision to bury a bull. You don't need hermetic seals. You don't need diorite, one of the hardest stones on Earth. So hard that even today we use diamond-tipped tools to cut it efficiently. So what were they really for? Some researchers, including engineer Christopher Dunn, believe the Serapeum boxes were acoustic signal amplifiers or piezoelectric generators. Their specific geometry, their material composition, their precision tolerances, all of it points toward a functional purpose related to resonance and energy generation.
And here's the thing that mainstream archaeology can't explain.
How did they make these boxes? How did they achieve micron-level precision with copper chisels? How did they transport and place 100-ton objects in cramped underground tunnels? The standard answer is, they were very patient and had lots of workers. But that's not an engineering answer. That's hand-waving. When you actually try to replicate these achievements with Bronze Age tools, you can't do it. Modern engineers have tried, they've failed. Which brings us to the central question. If they didn't use brute force and primitive tools, what did they use? The answer might be hiding in plain sight, encoded in the very stones themselves. Segment 2, the granite question. Piezoelectricity and resonance. Let's talk about why granite matters. Because the choice to use red Aswan granite for the internal chambers of the Great Pyramid wasn't just aesthetic, it was functional. Granite is a composite rock made up of several minerals, but the dominant component is quartz, specifically silicon dioxide. Depending on the specific granite, quartz can make up anywhere from 20% to 80% or more of the stone's composition. Analysis of the granite used in the King's Chamber has found quartz content as high as 84.659%. Why does that matter? Because quartz is piezoelectric. Piezoelectricity was officially discovered in 1880 by Pierre and Jacques Curie. They found that certain crystals, when subjected to mechanical stress, pressure, squeezing, vibration, generate an electrical charge. And conversely, when you apply an electrical field to these crystals, they vibrate. This is called the inverse piezoelectric effect. Quartz is one of the most piezoelectric materials in nature. This property is why quartz crystals are used in watches, radios, and electronic oscillators. When you vibrate quartz at a specific frequency, it generates a precise, stable electrical signal. And when you apply electricity to quartz, it vibrates at a consistent frequency. Now, imagine a chamber constructed from thousands of tons of quartz-rich granite. Imagine that chamber is designed to resonate at specific frequencies. When those frequencies are introduced, either from sound, from vibration, from the Earth's natural seismic activity, the quartz crystals in the granite start to oscillate. And as they oscillate, they generate electrical charges. Research using atomic force microscopy has shown that the local piezoelectric coefficient of quartz in granite is significantly larger than macroscopic measurements would suggest. In other words, the quartz crystals can generate substantial electrical potentials when subjected to vibrational stress. The Great Pyramid, according to this theory, wasn't a tomb, it was a power plant, a massive piezoelectric generator designed to convert the Earth's natural vibrations into usable electrical energy. This is the core of Christopher Dunn's Giza power plant hypothesis. Dunn, a master craftsman and engineer who worked in the aerospace industry for decades, analyzed the pyramid from a mechanical engineering perspective and concluded that it was a coupled oscillator system. Here's how the system supposedly worked. The Earth itself generates constant low-frequency vibrations. Seismic activity, tidal forces, temperature changes, all of these create mechanical oscillations in the planet's crust. The pyramid, sitting on the Giza Plateau, would naturally absorb these vibrations through its massive limestone base. The subterranean chamber, carved deep into the bedrock beneath the pyramid, may have functioned as a pulse generator. Some theories suggest it used groundwater or seismic pulses to initiate oscillations in the structure. There's an unfinished passage leading from this chamber that dead ends abruptly, and acoustic tests show this passage functions as a resonance tube, generating infrasound at approximately 5.13 hertz. Infrasound at these frequencies can't be heard by humans, but it can be felt. It affects consciousness, often inducing feelings of awe, dread, or an altered state of awareness. It also transmits through solid rock extremely efficiently. From the subterranean chamber, the vibrations would travel upward through the structure. The Grand Gallery, a steeply ascending corridor leading to the King's Chamber, is believed to have originally housed a bank of resonators. Dunn suggests there were 27 resonator units installed in the slots along the gallery's walls. These resonators would convert the mechanical vibrations traveling through the pyramid into airborne sound. This sound would then be focused into the King's Chamber. The chamber's dimensions, the relieving chambers above it, the granite construction, all of it designed to amplify specific frequencies. The massive granite beams in the ceiling would begin to vibrate sympathetically, their quartz crystals generating electrical charges. The Queen's Chamber, located below the King's Chamber, may have served a different function. Chemical analysis of the walls in the Queen's Chamber has revealed salt deposits. Dunn suggests this chamber was used to produce hydrogen gas through a chemical reaction, possibly mixing hydrochloric acid and zinc chloride delivered through the northern and southern shafts. Hydrogen gas would then be pumped into the King's Chamber, where the intense acoustic vibration and the electrical fields generated by the piezoelectric granite would ionize the hydrogen, creating a plasma state. The northern shaft of the King's Chamber, aligned precisely with the star Thuban, may have allowed a microwave signal from space to enter the chamber, interacting with the energized hydrogen to create stimulated emission of microwave energy. In other words, the pyramid might have been a MOSR, a microwave amplification by stimulated emission of radiation device, the ancient equivalent of a laser, but using microwaves instead of visible light.
Now, does this sound far-fetched? Absolutely. But here's the thing. The evidence fits.
The precision engineering, the choice of materials, the specific dimensions, the astronomical alignments, the chemical residues, the lack of soot suggesting alternative lighting, all of it supports a functional interpretation rather than a ceremonial one.
And there's another piece of evidence that's even more compelling. The pyramid demonstrably concentrates electromagnetic energy.
In 2018, researchers at ITMO University in Russia used electromagnetic modeling to analyze how the Great Pyramid interacts with radio waves. They found that the pyramid's shape and composition allow it to concentrate electromagnetic energy in its internal chambers, even from ambient environmental radiation. The pyramid isn't just a passive pile of rocks, it's an antenna, it's a resonator, it's a machine designed to interact with electromagnetic and vibrational energy. But even if we accept that the pyramid was designed as some kind of energy device, that still doesn't explain how it was built. How did they cut, transport, and place all those stones with such precision? The answer might lie in the same property we've been discussing, resonance. Because if the ancient Egyptians understood how to use sound to generate electrical energy, they might also have understood how to use the sound to manipulate matter itself. They might have known how to make stone float. Segment 3. Acoustic levitation. The physics of floating stone. Acoustic levitation sounds like science fiction, but it's not. It's real, proven, and has been demonstrated in laboratories that are around the world. The basic principle is this. Sound is a pressure wave moving through a medium. When you create a standing wave, a wave that oscillates in place rather than traveling, you create nodes and antinodes. Nodes are points of low pressure. Antinodes are points of high pressure. If you can create a strong enough standing wave, you can position an object at the nodes where the acoustic radiation force pushes upward against gravity. The object becomes suspended in mid-air, levitating without any physical support. This has been done with liquid droplets, small animals, polystyrene balls, and even living cells. In 2016, researchers in the UK and Brazil successfully levitated a 50mm polystyrene ball using acoustic waves, demonstrating that objects larger than the wavelength of sound could be suspended. The mathematics behind this is described by the Gorkov potential, which models how particles are pushed toward the nodes of a standing wave. It's real physics, peer-reviewed and replicated. But there's a problem: scaling. To levitate an 80-ton granite block using acoustic levitation would require sound levels in excess of 200 decibels. For context, a jet engine at close range is about 140 decibels. 200 decibels would be instantly lethal to any unprotected human. The power density required would be immense, and the engineering challenges would be extraordinary. So the question becomes, is there any evidence that the ancient Egyptians understood and used this technology? And the answer is yes. Not physical artifacts necessarily, but historical testimony. Lots of it. The most detailed account comes from the 10th century Arab historian Abul Hassan Ali al-Masudi, often called the Herodotus of the Arabs. Al-Masudi recorded oral traditions describing how the massive blocks were moved during the pyramid's construction. According to these accounts, a magic papyrus with symbols inscribed on it was placed under a stone block. Once the papyrus was positioned, a metal rod was struck against the stone. The stone would then levitate and move along a paved pathway. The path was fenced on either side by metal poles, which some researchers interpret as waveguides or resonators maintaining the acoustic field. The stone would reportedly travel about 50 meters through the air before settling down. Then, the process would be repeated until the stone reached its destination. Now, mainstream academics dismiss this as legend, as myth, as impossible. But notice the specifics. This isn't a vague story about magic. It describes a process. A papyrus placed under the stone, possibly optimizing the coupling between the acoustic field and the mass. A metal rod struck against the stone, initiating the vibration. Metal poles along the pathway, maintaining the resonance. This reads like an operational manual, not a fairy tale. And it's not just al-Masudi. Coptic legends and Islamic traditions speak of the pyramids being built before the Great Flood by a king named Surid, often identified with Hermes or Enoch. These accounts say the stones were moved by musical instruments, by chance, by striking them with wands. One legend states that builders only had to whistle at the stones to move them into place. Similar traditions exist in other megalithic cultures. At Tiahuanaco in the Andes, local legends say the stones were carried through the air to the sound of a trumpet. In Easter Island, tradition holds that the Moai statues walked to their positions through mana, spiritual energy often associated with sound and vibration. Are all of these cultures independently inventing the same impossible story? Or are they preserving a memory of a real technology that's been lost?
There's a modern parallel that suggests this might not be as impossible as it seems.
A Latvian immigrant named Edward Leeds-Kalnin single-handedly built a structure called Coral Castle in Florida. Leeds-Kalnin was 5 feet tall and weighed 100 pounds. He quarried and moved over 1,100 tons of coral rock, including individual pieces weighing up to 30 tons. He used no heavy machinery. He worked almost entirely at night, alone, and refused to let anyone watch him work. When asked how he did it, Leeds-Kalnin said he had found out how the Egyptians and the ancient builders in Peru, Yucatan, and Asia raised and set in place blocks of stone weighing many tons. He never revealed his exact methods, but we know he had a deep interest in magnetism and owned radio equipment. Some witnesses claim to have seen him float coral blocks, like hydrogen balloons. Others reported seeing him use strange cone-shaped objects that emitted sound. After his death, researchers have speculated that Leeds-Kalnin understood some principle of acoustic or electromagnetic levitation. He left cryptic writings about magnetism and energy, but nothing definitive. The point is, a single person with no formal education and no machinery moved over 1,000 tons of stone using some method we don't understand. If he could figure it out in the 20th century, why couldn't the ancient Egyptians, with institutional knowledge passed down through generations of priest engineers? There's even inadvertent modern proof that vibration can move stone. At the Manchester Museum, an ancient Egyptian statue of a man named Neb-Sinu started rotating inside a locked glass display case. Over the course of days, the statue would slowly turn 180 degrees, always in the same direction, and then stop. Paranormal investigators had a field day, but when vibration experts analyzed the phenomenon, they found the answer. The statue had a slightly convex base. Subtle vibrations from traffic, footfall, and building systems were amplified by the statue's shape, causing it to rotate in a precise, consistent manner. This wasn't magic, it was physics. But it demonstrated that if you understand resonance, if you understand how to shape stone and apply specific frequencies, you can make solid objects move in ways that seem impossible. Now imagine scaling that principle up. If subtle environmental vibrations can make a small statue rotate, what could focused, high-intensity acoustic waves do to a massive block of stone? Could they reduce its effective weight? Could they make it movable by a small number of workers instead of thousands? Some researchers suggest the ancient Egyptians weren't actually levitating stones in the sense of making them float freely. Instead, they were using infrasonic or ultrasonic frequencies to reduce the friction between the stone and the ground, or to create a cushion of vibrating air beneath the block, making it effectively frictionless. Others suggest they were using sympathetic resonance. If you can make a stone vibrate at its natural frequency, you can dramatically reduce the energy needed to move it. It's like pushing a child on a swing. If you time your pushes correctly, matching the swing's natural rhythm, you can achieve huge motion with minimal effort. Push at the wrong time, and you work much harder for less result. The magic papyrus Al-Masudi described might have been a material that optimized the acoustic coupling between the sound source and the stone, or it might have been inscribed with the specific frequencies and rhythms needed for that particular block, like a musical score for a moving stone. The metal rod might have been a tuning fork or a piezoelectric striker, initiating the vibration. The metal poles along the path might have been resonators, keeping the stone vibrating at the correct frequency as it moved. This all sounds fantastical, I know, but consider the alternative, that thousands of workers with copper chisels, wooden sledges, and rope moved 2.3 million blocks, weighing a total of 6 million tons, achieving micron-level precision, geodetic alignment, and acoustic resonance properties, all by accident while building a tomb.
Which explanation actually sounds more far-fetched?
Segment 4. The was scepter and ancient sound technology. If the ancient Egyptians did use acoustic technology to build the pyramids, we'd expect to find some evidence of it in their art, their symbols, their tools. And we do. It's been hiding in plain sight for thousands of years. Look at any depiction of Egyptian gods or pharaohs, and you'll often see them holding 3 objects: the ankh, the Jed pillar, and the was scepter. The ankh is universally recognized as the symbol of life, but it's shaped like a loop with a cross beneath it. Some researchers suggest it represents an electrical circuit or an energy flow diagram. The Jed pillar is described as a symbol of stability, but its structure, a vertical shaft with 4 or 5 horizontal platforms, resembles a resonance column or an inductor coil. And then there's the was scepter. It's a staff with a forked base and a stylized animal head at the top, frequently shown being carried by gods and pharaohs as a symbol of power or dominion. But look at that forked base. It's shaped exactly like a tuning fork. A tuning fork is one of the simplest acoustic devices. Strike it, and it vibrates at a precise frequency, generating a pure tone. Tuning forks are used to tune musical instruments, to calibrate oscillators, and in modern acoustic testing. Could the was scepter have been a functional tool rather than just a symbol? Could it have been used to initiate vibrations in stone blocks during construction? Some depictions show the was scepter being used in ways that suggest it was partially embedded in the ground or in stone blocks. The stylized head might have been a handle designed to be gripped at a specific angle during operation. When combined with the ankh and the Jed pillar, these objects might have formed a complete system for generating, modulating, and directing acoustic energy. There's even evidence suggesting the was scepter could have been a drill bit. Relief carvings show it being used in positions that suggest rotational motion or penetration into stone. If you attached a was scepter to a Jed-like resonance column and drove it with rhythmic acoustic pulses, you might have a primitive but effective sonic drill. Christopher Dunn, the engineer who proposed the Giza power plant theory, has extensively documented evidence of advanced machining in ancient Egypt. He's found saw marks in granite blocks that suggest blade speeds and feed rates consistent with modern industrial equipment. He's found drill cores that show spiral grooves, indicating a drilling rate far beyond what copper tools could achieve. The mainstream explanation is that these are just random scratches, or that the Egyptians were incredibly patient and used sand as an abrasive. But Dunn, who has decades of experience in precision machining, says that's not physically possible. The evidence, he argues, points to high-frequency sonic drilling and sawing. If you could vibrate a tool at ultrasonic frequencies, above 20,000 eighths, you could cut through granite like butter. The vibration would shatter the crystalline structure of the stone at a microscopic level, while water and abrasive slurry would flush away the debris. This is actually how modern ultrasonic cutting tools work. Could the ancient Egyptians have had ultrasonic tools powered by the same piezoelectric and acoustic principles we've been discussing? Could the symbols we interpret as religious iconography actually be engineering diagrams for a lost technology? There's more evidence in the acoustic properties of the chambers themselves. The king's chamber resonates at approximately 117 to 121 hertz, depending on how it's measured. This frequency is well within the range of the human male voice and is also associated with the musical note of B-flat. But more interestingly, it's close to frequencies used in modern sound healing and meditation. Some researchers have measured other resonant frequencies in the pyramid's chambers, including 432 Hz and 528 Hz. These frequencies are often called sacred frequencies in New Age circles, but they also have documented physiological effects. 432 Hz is said to resonate with water molecules and human cells. 528 Hz is associated with DNA repair in some alternative healing modalities. Whether or not you believe in the healing properties, what's undeniable is that the chambers were designed to resonate. The dimensions weren't chosen randomly. They were calculated to create specific acoustic properties. The granite sarcophagus in the king's chamber is particularly telling. It's carved from a single block of Aswan granite and weighs several tons. When struck, it produces a deep, sustained, resonant tone. Acoustic studies show that the sarcophagus is acoustically coupled to the chamber, meaning sound energy in the room transfers into the stone itself. If you wanted to activate the piezoelectric properties of granite, this is exactly what you'd do. You'd create a resonant chamber tuned to specific frequencies, you'd place a massive chunk of quartz-rich granite in the center, and you drive the whole system with sound until the stone began to vibrate and generate electrical charges. The subterranean chamber beneath the pyramid has its own acoustic properties. The dead-end passage extending from this chamber functions as a resonance tube that generates infrasound at approximately 5.13 Hz. This is well below the range of human hearing, but it's within the range of the Schumann resonance, the fundamental frequency of the Earth's electromagnetic field, which is about 7.83 Hz. Some theorists suggest the pyramid was designed to couple with the Earth's natural frequency. The subterranean chamber would capture the Earth's seismic vibrations and the Schumann resonance. The Grand Gallery would amplify them into audible frequencies, and the King's Chamber would focus them into usable energy. This isn't speculation about ancient magic. This is engineering analysis based on measurable properties of the structure. And it raises a profound question. If the ancient Egyptians understood acoustics, resonance, and piezoelectricity well enough to design a power plant, couldn't they also have used these principles during construction? Segment 5, the bigger picture. A lost science of sound. Let's step back and look at the bigger picture, because the Great Pyramid isn't an isolated anomaly. It's part of a larger pattern of megalithic construction around the world that defies conventional explanation. At Baalbek in Lebanon, there's a stone block weighing 1,650 tons still sitting in the quarry. It's called the Stone of the Pregnant Woman. And there are stones nearly that large already incorporated into the temple platform at Baalbek. Then they had technology far beyond ropes and ramps. At Pumapunku in Bolivia, there are H-blocks made of andesite, one of the hardest stones on Earth, cut with precision that rivals modern CNC machining. The blocks have perfect right angles, smooth surfaces, and interlocking joints that suggest they were mass-produced using templates. At Göbekli Tepe in Turkey, massive T-shaped pillars weighing up to 50 tons were carved, transported, and erected 11,000 years ago. thousands of years before the supposed invention of agriculture or settled civilization. At Stonehenge, bluestones weighing up to 4 tons were transported 140 miles from Wales to Salisbury Plain, and the larger sarsen stones, weighing up to 50 tons, were shaped and positioned with astronomical precision. In every case, mainstream archaeology offers the same explanation. Lots of workers, lots of time, lots of patience. But when modern researchers try to replicate these achievements using the tools and methods available to ancient people, they consistently fail or produce results that don't match the precision of the originals. What if all of these sites are evidence of the same lost technology? A science of sound and vibration that allowed ancient cultures to manipulate massive stones in ways we can barely imagine. This knowledge might have been closely guarded, passed down through generations of priest engineers. In Egypt, the priests of Ptah were associated with craftsmanship and building. In their temples, secret knowledge was preserved and taught only to initiates. When civilizations collapsed, whether through war, climate change, or other catastrophes, this knowledge would have been lost. The pyramids would have remained, but the understanding of how they were built would have disappeared. Later cultures would look at these structures and invent stories to explain them. Gods and giants, magic and divine intervention, because the truth, that their ancestors had a sophisticated understanding of physics and engineering, had been forgotten. But hints of the truth survived in oral traditions, the stories of stones being moved by sound, the depictions of gods holding what might be acoustic tools, the persistent legends across cultures that speak of a time when humans could command stone through vibration and song. Modern science is only now beginning to catch up to what the ancients might have known. The Great Pyramid, from this perspective, isn't just a tomb or even just a power plant. It's a message, a demonstration of what's possible when you understand the fundamental principles of vibration and resonance. It's a technology frozen in stone, waiting for us to decode it. And the evidence is everywhere. The precision of the construction, the choice of piezoelectric materials, the acoustic properties of the chambers, the astronomical alignments, the historical accounts of acoustic levitation, the symbols that might be engineering diagrams, the modern parallels that prove the principles are sound. All of it points toward the same conclusion. Our ancestors were far more sophisticated than we've been taught to believe. The question is no longer whether the pyramids could have been built with sound. The question is, why have we been so resistant to considering the possibility? Maybe it's because accepting this theory means accepting that an enormous amount of what we've been taught about ancient history is wrong. It means acknowledging that civilizations rise and fall, that knowledge can be lost, that we might not be the pinnacle of human achievement, but rather rediscoverers of ancient wisdom. It's a humbling thought, and maybe that's why mainstream academia fights so hard against it. But the stones don't lie. The precision doesn't lie. The physics doesn't lie. And when you stand in the king's chamber and feel the resonance, when you strike the sarcophagus and hear it ring, when you see the perfect alignment and the impossible tolerances, you know in your bones that something extraordinary happened here. Something we're only just beginning to understand. So here we are. We've explored the precision engineering of the pyramids, the piezoelectric properties of granite, the physics of acoustic levitation, the historical accounts of sound-based construction, and the symbols that might represent lost acoustic technology. We've looked at the Giza power plant theory, the resonance properties of the chambers, the evidence of advanced machining, and the modern parallels that prove these principles are real. And we've asked the fundamental question, how were the pyramids actually built? The honest answer is, we don't know for certain. We may never know. The knowledge, if it existed, has been lost for thousands of years. But the conventional explanation, copper chisels, wooden sledges, and unlimited patience, doesn't fit the evidence. It doesn't explain the precision. It doesn't explain the choice of materials. It doesn't explain the acoustic properties. It doesn't explain the consistent accounts across cultures of stones being moved by sound. The acoustic levitation theory, wild as it sounds, actually explains more of the evidence than the standard archaeological model. It explains why granite was chosen for the king's chamber. It explains the resonant properties. It explains the precision. It explains the historical accounts. It even explains why there's no soot in the chambers. if they were lit by piezoelectric glow or designed to operate without human presence during activation. Whether the ancient Egyptians fully levitated stones through the air or simply used resonance to reduce friction and effective weight, the principle is the same. They understood something about sound and vibration that we're only now rediscovering. And maybe that's the real lesson here. Not that the pyramids were built by aliens or lost super civilizations, but that human knowledge isn't linear. We don't constantly progress forward. Sometimes we lose things. Sometimes catastrophic events wipe out generations of accumulated wisdom. Sometimes knowledge is deliberately hidden or destroyed. The pyramids stand as monuments to what we've forgotten. They challenge us to look beyond the conventional explanations and consider possibilities that seem impossible. They invite us to rediscover lost sciences, to question our assumptions, to acknowledge that our ancestors might have been far more capable than we give them credit for. The next time you see an image of the Great Pyramid, don't just see a pile of stones stacked by primitive laborers. See a machine, see a resonator, see a technology frozen in granite waiting for us to remember how it works. And listen, because the pyramids are still singing, still resonating at frequencies we're only beginning to detect. The stones are trying to tell us something. Maybe it's time we finally learned how to listen.
Thanks for joining me on this journey through one of history's greatest mysteries. Until next time.